Welcome to the Deep Dive. Today we're tackling a topic that, well, really hits home for comfort in your budget: HVAC maintenance.
Absolutely.
Think of this as your guide to understanding what keeps that system running, smoothly, and maybe how to spot headaches before they get really big.
Exactly. And we've pulled together a few different angles for you. We've got some DIY advice from a homeowner on Reddit, a really detailed pro checklist, and then some troubleshooting scenarios, like real-world problems.
Right. The mission here is really to help you feel more informed about your own system, understand the basics, maybe recognize a problem brewing, and honestly appreciate what the pros do.
Couldn't have said it better.
Okay, so let's jump in. That Reddit DIY approach, what's the main idea there?
So this homeowner was basically making the case that for a lot of people with standard central systems, those routine professional maintenance plans, maybe not always essential if you're willing to do some basic upkeep yourself.
Trying to save some money, makes sense. What kind of upkeep are we talking about?
Pretty straightforward stuff, actually. First, keeping the area around your outdoor unit, the condenser, and the indoor unit, the air handler, clear.
How clear?
They recommend at least 2 feet of clear space all around.
Yeah, that just feels like common sense, doesn't it? The system needs room to work, to breathe.
Precisely. Blocking airflow is a huge drag on efficiency. It can really strain the components, too.
Okay. What else is on the DIY list?
Filters. Big one. And this part was interesting. They mentioned an experiment.
Okay.
Yeah, showing how airflow drops off over time, even if you think you're changing the filter often enough. They measured like a 10–15% reduction after just 30 days.
Wow, only 30 days.
And it got worse. By 90 days, for a standard single-speed air handler, they saw a 30–35% drop in airflow.
Okay, that definitely makes you look twice at those change every 3 months labels.
Yeah.
So what filters do they recommend for DIY?
For most homes, they suggest sticking to MRV 6 to 8 or MPR 600, FPR 5. Those are other rating systems you might see.
MRV, that's the filtration level, right? Higher is better.
Generally, yes. MRV stands for Minimum Efficiency Reporting Value, basically how well it catches tiny particles. But, and this is a really key point they made, those really thick, high RV filters, they can actually restrict airflow too much if your system wasn't designed for them.
Okay, so it's a trade-off. Better filtration, but potentially less air moving.
Exactly. You don't want to choke the system.
Got it. What else? Rinsing coils.
Yep. The outdoor condenser coils, they suggest rinsing them down with a garden hose every 6 months or so.
Just water, no chemicals.
The idea is if you do it regularly, you prevent major gump from building up, so maybe you avoid needing harsher cleaners later.
Smart. Preventative.
And then there's the condensate drain line, that little PVC pipe, usually near the indoor unit.
Right. Handles the moisture.
Yeah. Key is making sure water flows freely. They suggest checking it, maybe popping the cap off while it's running to see water moving, using drain cleaning tablets or a little cleaner sometimes.
Some commenters mentioned vinegar, too, or even a shop vac.
Yeah, those came up as ways to clear clogs if they happen.
So these all sound like things a reasonably handy person could do, like the poster said. But the comments on that thread brought up other points, didn't they, like warranties?
That's a really important counterpoint. DIY is great, but you absolutely need to think about the manufacturer's warranty.
How so?
Well, a lot of manufacturers now require proof of regular professional maintenance to keep that warranty active, especially on newer, maybe more complex systems.
So skipping the pro could actually void your warranty.
It potentially could, yeah. If a major part fails and you can't show it's been professionally maintained, they might deny the claim. This is where groups like ACCA, the Air Conditioning Contractors of America, really stress using qualified techs. Their standards often line up with what manufacturers want for warranty purposes and, peak performance.
So even if you are doing the DIY stuff, keeping records seems crucial, like receipts for filters.
Absolutely. Proof of purchase for filters, cleaning supplies, maybe just a simple log of when you did the cleaning. It could help if a warranty question comes up.
The Reddit poster did mention that for the labor part of a new unit warranty, a pro plan is often required, right?
Right. Their main argument was more about the routine stuff, the simple cleaning and filter changes that don't need specialized gear.
Okay, so that gives us a good sense of the DIY angle and its limitations. Let's pivot to that professional checklist. You said it's pretty intense.
Oh, it's incredibly thorough. We're talking multiple pages covering everything imaginable. It really shows the level of detail a certified technician brings, often following those ACCA standards or specific PMA's product maintenance manuals, maybe from a manufacturer like Hartzell.
Let's walk through a few key areas. We talked about clearing space outside. What does the Pro checklist look at for the outside air intake?
Way beyond just clear space, they're checking the exact location. Is it away from contaminants like standing water, exhaust fumes, trash areas, bird stuff?
Things you didn't even think about.
Exactly. They check the bird screen. Is it intact, right? Mesh size. And the dampers that control fresh air, do they work right? Do they seal properly?
And then measuring the outdoor air quantity. Why is that critical?
It's all about healthy indoor air and proper ventilation. They check if the amount of fresh air meets code, sometimes referencing specific standards like HHRA 62. They measure the actual percentage coming in.
HHRE.
Yeah, it's an engineering society that sets standards for building systems. They also check how it works in different system types, like VAV systems, to make sure enough fresh air is always circulating.
Okay. Then the mixing plenum, where inside and outside air combine.
Crucial spot. They check for cleanliness, make sure the drain is trapped right so no sewer gas gets in, and crucially, check that all the dampers outside, return, exhaust, are airtight.
Even small leaks matter there.
Oh, yeah. Leaks waste energy and mess up ventilation. They also check the damper motors.
And filters obviously get a close look.
Definitely. More than just the type. Does it cover completely? No air sneaking around the edges? Is the pressure drop across it what the manufacturer recommends? Any weird smells or visible gunk? If there are humidifiers or air washers, that's a whole other inspection list for nozzles, pans, biocide treatment.
Wow. Okay, what about inside, like the cooling coil and drip pan?
Super detailed check there. Cleanliness, obviously, but also water temperature, any signs of water getting blown off the coil, condensation issues, accessibility for cleaning, any residue, standing water, leaks, smells, visible mold or growth, and the drain and trap condition. Lots of potential moisture problems there if things aren't right.
Makes sense. Moisture equals potential trouble.
Then they move to the supply fan chambers and the fans themselves. Cleanliness again, making sure nothing's stored there.
Like using it for storage. Bad idea.
Very bad. They check drains are trapped, look for air leaks, make sure access doors seal tightly. Then the fan blades themselves clean, damaged, corroded, belt guards, belt tension, any vibration, corrosion checks, control calibration.
Just keeps going.
It really does. The full checklist goes on to heating coils, ductwork, plenums, thermostats, exhaust fans, makeup air, the mechanical room itself, even boilers and cooling towers in bigger buildings. Following those ACCA guidelines or specific PMAs ensures nothing gets missed.
It paints a very clear picture of why professional maintenance is so comprehensive. It's not just a quick look-see.
Not at all. It's a deep diagnostic check.
Okay, that brings us nicely to the last source. The troubleshooting scenarios. These show what happens when things go wrong.
Right. These are like case studies from technical training. They show how problems appear and how techs figure them out. Let's take the first one. A bad transformer installation.
What happened there?
So a tech replaced a transformer but wired the new one wrong. They connected the primary side, the incoming power, to the wrong spot basically after the contactor switch instead of before it.
Uh-oh.
Effect. The unit wouldn't start on its own. You had to physically push the contactor button to get it going. Shows how critical correct wiring is. Basic electricity, but easy to mess up.
Definitely. What's another example?
There was one with a faulty thermostat subbase. The complaint was the AC compressor and the outside fan were running, but the indoor fan wasn't. No air moving inside.
Weird. What was it?
Turned out the contacts for the IU2 fan setting inside the thermostat subbase, the part mounted on the wall, had failed. So even though the AC was getting the signal, the fan wasn't. A small part causing a big problem.
Shows how interconnected it all is. What about low refrigerant? That sounds common.
Very common. The scenario described the unit starting up, running for just a bit, then shutting down. Start, run, stop. Over and over.
The sign.
When they put gauges on, the low side pressure dropped way down just before it shut off. That cycling is a classic sign the system doesn't have enough refrigerant. The low pressure safety switch is doing its job, shutting it down.
Okay. And a failed blower motor. How did that show up?
That one started with an error code on the furnace control board. The code pointed to an open limit switch.
A safety switch.
Right. The tech checked the limit switch, and sure enough, it was open, no electricity flowing through. Digging deeper, they found the indoor blower motor itself was completely dead and open winding.
So the motor failed, airflow stopped, things overheated, and that tripped the limit switch.
Exactly. A domino effect. Failure in one spot triggers safety measures elsewhere.
Last one, the dirty indoor coil. What was the symptom?
Homeowner just said it wasn't cooling well. Technician arrives, outdoor unit is running, the refrigerant line feels cold, so the cooling part seems to be working, at least somewhat.
Yeah.
But the airflow coming out of the vents inside was really weak. And here's the clue. When the tech took the access panel off the indoor unit, the airflow suddenly increased a lot.
Indicating a blockage before the fan.
Precisely. And since there was no filter actually in the filter slot, just the cover, the likely culprit was a really dirty indoor evaporator coil blocking the air. Taking the panel off gave the air an easier path.
These examples really make it click, how one thing affects another and how techs track down the root cause.
Yeah, it's systematic detective work.
So, wrapping this all up, what are the big takeaways for someone listening?
I think there are a few key things. One, doing that basic DIY stuff filters, keeping things clear, really can make a difference in efficiency and, maybe preventing bigger problems.
Simple but effective.
Two, that professional checklist. It shows just how much goes into a proper checkup. It's complex, detailed, and follows industry standards like ACCOs for a reason, ensuring safety, efficiency, good air quality.
Respect the pros.
Definitely. And three, those troubleshooting stories show that while symptoms might seem straightforward, the actual cause can be tricky to find. It takes knowledge and a methodical approach.
And it reinforces that while DIY is good for the basics, messing with complex electrical stuff, refrigerant, or major parts is probably best left to the licensed professionals, right?
Absolutely. You could easily make things worse, create a safety hazard, or, like we said, void that warranty.
The goal today wasn't to make everyone an HVAC tech overnight.
No, not at all. It was about giving you a better understanding. Being informed helps you spot issues earlier, talk more effectively with a tech when you do need one, and just generally take better care of a really important, expensive system in your home.
Well said. So here's something to chew on. Take a minute, maybe later today, and just look at your own system with this stuff in mind. Where's your filter? When was it last changed? Is the area around the outdoor unit clear? What else are you curious about now? That's the point of a deep dive, right?
Yeah.
Sparking that curiosity.
Couldn't agree more.
Thanks for joining us.